Welcome to Biostatistics PDZE 511 Revision Questions and Solutions. Question 1. The following are measurements of initial and final weight of rat in an experiment. In this table, IW represent initial weight in grams, while FW represent the final weight in grams. Using Microsoft Excel, calculate 1. The mean of the initial weight and final weight. 2. The standard deviation of the initial weight and final weight. And 3. The standard error of mean of the initial weight and final weight. Solution. Using Microsoft Excel, this problem can be solved in two ways, either computationally or by using Analysis Toolpack. Here we are going to use the computational method. To use this method, the first thing you have to do is to open a Microsoft Excel workbook. This is a Microsoft Excel workbook. Once the workbook is open, we can then enter our A1, A22, A9 and also enter the final weight data in cells B1, B22, B9. This is what I mean. These are the initial weight data, while this one are the final weight data. Next is to find the sum of the initial weight data and the final weight data. To find this sum, all we need to do is to highlight cells A1, B1 to cells A10, B10. Then click on the Auto Sum button. This value 1211 will appear in cell A10, that's the sum of this, while this value 2079 will appear in cell B10, which is the sum of this. Next is to find the mean of the initial weight data, which is obtained by dividing the value in cells A10 by 9. That's 1211 divided by 9. That will give us 135. The mean of the final weight data is x bar b equal to, divide the value here 2079 by 9, and that will give us 231. Now, to calculate the standard deviation of the two sets of data, we have to find the sum of squares of the deviations from their means. To do that, in cell C1, type this command, equal to, in bracket, A1 minus 135 cap 2. Then press enter. This value will appear 1764. That is the square of the deviation of 177 from the mean 135. Also in cell D1, type this command, equal to B1 minus 231 in bracket cap 2. Press enter. This value 64 will appear. That is the square of the deviation of 223 from the mean 231. Once these two values are obtained, you can then copy the content of C1 and D1 and paste in the rest of the cells, and these values will appear. Then to find the sum of the squared deviation for the initial weight data and the final weight data, you have to highlight these two cells to C10 and D10. Then click the auto sum button. This value 4452 will appear in cell C10. That's the sum of squares of deviation of the initial weight data from the mean. While 72 will appear in cell D10, the sum of squares of deviation of the final weight data from the mean. Having done this, that is the formula for finding the variance. 1 all over n minus 1 divided by x minus x bar squared. That is, to find the variance, you have to divide 4452 by n minus 1, that's by 8. Also divide 72 by 8. That will give us the variance of the initial weight data and the final weight data. To calculate the standard deviation, we have to take the positive square root of the two variances. So the standard deviation of the initial weight data denoted by SA is equal to 23.6, while the standard deviation of the final weight data SB is equal to 3. C. To compute the standard error of mean of the initial weight data, it is given by SA over the square root of n. That is 23.6 over square root of 9. That is 23.6 divided by 3, and that will give us 7.9. The standard error of mean of the final weight data is SB over square root of n. That's equal to 3 over square root of 9, and that will give us 1.0. Question 2a. The mean weight of farm tilapia in Nigeria is given as 60 grams. But the mean weight of tilapia sampled from 200 fish farms in Cross River State was found to be 65 grams, with a standard deviation of 15 grams. Is the mean weight of Cross River State tilapia significantly different from the national mean? Solution. Here we are testing the null hypothesis H0 mu equal to 60 against the alternative hypothesis H1 mu is not equal to 60. This is a two-tailed test because the alternative hypothesis is stated with not equal to sign. Here the sample size n is 200, the sample mean x bar is 65, while the standard deviation s is 15. The test statistic for this hypothesis is z equal to x bar minus mu divided by s divided by square root of n, which is equal to 65 minus 60 all over 15 times square root of 200, and that will give us 4.71. Using alpha equals to 0.05 significance level, the critical value of our test statistic z is z alpha over 2. We are dividing alpha by 2 because it is a two-tailed test, and that will be equal to z 0.025. From the standard normal table, this will give us 1.96. Conclusion. The test is significant at 5% level, since the calculated value of our test statistic z, which is 4.71, is greater than the table value 1.96. We therefore conclude that the mean weight of Cross River State tilapia is significantly different from the national mean. Question 2b. Scores in biology for 12 students attending the same extramural classes in UTME and post-UTME are given below. Is there any significant difference in the scores between the two examinations? Solution. We present the given data as shown in this table. Scores on UTME are in column A, and the total score is 402. Scores on post-UTME are in column B, and the total score is 460. Here we are testing the null hypothesis mu A equal to mu B. That is, the two mean score are equal. We are testing this against the alternative hypothesis H1. Mu A is not equal to mu B. That's the mean score for the two exams are not equal. Again, this is a two-tailed test. Here the sample size NA is 12 and NB is 12. We calculate the sample mean X bar A, that is 402 divided by 12. That will give us 33.5. The sample mean X bar B is 460 divided by 12, and that will give us 38.3. We calculate the sample variance using the formula 1 all over n minus 1 sum x minus x bar squared. Here is the column for x minus x bar all squared. That is, you subtract the mean of A from each value here and square. That will give you this column. For B, you subtract the mean, which is 38.3, from the values here and square. That will give you this column. So the sum of squares of the deviation from the mean for the first set of data is 617, and for the second set of data is 282.68. So the variance of the first set SA squared is 617 over 11, which equal to 56.1, while the variance of the second set SB squared is 282.68 divided by 11. That will give us 25.7. The test statistics for this hypothesis is a t-test statistics. T equals to x bar B minus x bar A all over the square root of variance of A divided by NA plus variance of B divided by NB. This has a t distribution with NA plus NB minus 2 degrees of freedom. This is equal to, putting in the values, we have 38.3 minus 33.5 all over the square root of 56.1 over 12 plus 25.7 over 12. This will simplify to 1.84. Degrees of freedom is NA plus NB minus 2, that is 12 plus 12, 24 minus 2, that will give us 22. For alpha equals to 5% and 22 degrees of freedom, the critical value of our test statistics T is T alpha over 2 with 22 degrees of freedom. We are dividing alpha by 2 since the test is a two-tailed test. This is equal to T 0.025 with 22 degrees of freedom. From the student T table, this will give us 2.07. Conclusion. The test is insignificant since the calculated value of our test statistics T, which is 1.84, is less than the table value 2.07. We therefore conclude that there is no enough evidence to refute the claim that the two sets of data are the same.